Okay, so in this video, we will deal with multivalent cations. So we're still dealing with ionic compounds, and we will deal with multivalent cations in a binary compound, and then we will put them into polyatomic compounds. So we will make a multivalent cation part of, combine it with a polyatomic ion to make a compound. So take a look then at this paper in your package. So elements with more than one valence or charge or oxidation number, they are multivalent metals. And these all mean the same thing. So valence, charge, and oxidation number, all the same. So here's a chart, and it shows you some of them, or a good portion of the multivalent elements, ones you're going to encounter, and the classical system and the stock system. So we call the classical system, or the us-ich system, just to help us remember that the lower charge has the ending us, and the higher charge has the ending ich. The stock system, or also called the Roman numeral system, the IUPAC system, gives Roman numerals for the charges of the metals. So pretty simple, this will follow in the name. So iron 2 chloride, for example, if it was a 2, and iron 3 chloride if it was a 3. So let's take a look at these two systems and practice naming them. So with the stock system, as I mentioned, it is the IUPAC system, the Roman numeral system. This is the only time you're going to use a Roman numeral in naming. So to write formulas, the method is the exact same as the method for simple binary ionic compounds. What is different is the naming. To name these compounds, a bracket is placed after the name of the metal with the charge of the metal in the bracket in Roman numerals. The non-metal still changes its ending to IDE. So if we were to look at iron 2 and iron 3, as I mentioned, so we would have the elements iron with a charge of +2 and chlorine with a charge of -1. So we would cross those charges over, and we would end up with FeCl2. And if it has a charge of 3, we would have FeCl3. And if we are to name this, if we are to name it, we would take the number at the end, and that would be the Roman numeral in the middle. Okay, so, oops. So this would be the Roman numeral. So it would be iron 2 chloride. Okay, and this would be iron 3 chloride. Okay, so it's a pretty simple naming system. For the classical system, called the us-ich system, as I mentioned, us would be us is for the lower charge. I got this backwards here. Us is for the lower charge, and ich is for the higher charge. and we still change the name of the ending of the nonmetal to "ide." So we would name this one, ferrous chloride. It is lower, and ferric chloride. I just realized I couldn't see anything there. So us for the lower number and ic for the higher. So we obviously can't use the classical system if there's more than 2 charges, which isn't very often, but can't be used. So lastly, for the ionic compounds, or with metals and polyatomics, we are going to look at polyatomic ions. So they are also called ternary and quaternary compounds, and they contain 3 and 4 elements. They're also called salts. Radicals, or polyatomic ions, stay intact when substances react and behave as though they are single particles, and as a result are given distinct names. So I've mentioned all these already. We already went over these. We've got common radicals, or polyatomic ions. I know this is a bit repetitive, but that's okay. It's okay if we repeat ourselves. So you had to memorize the ones that I told you. These guys right below in this chart. So that was sulfate, chlorate, carbonate, nitrate, and phosphate. So if we name normal compounds made from radicals, all the rules that apply for ionic bonding in naming the first element, which is a metal, or positively charged radical. The only one that we really know of is ammonium, NH4 with a charge of +1. That's the only one that we will be using. They remain the same. The negatively charged radical is given its full name, no changing. So, in this case here, iron, Fe bracket NO3 bracket 3 contains iron 3, or a ferric ion and nitrate ion. So what's the charge on this? That 3 would be with the iron, and charge would be -1. And so we would call this iron 3 nitrate in the stock system, or ferric nitrate in the classical system. How do we write compounds made of radicals? So again, note all the rules apply in writing the formula when univalent with 1 charge and multivalent 2 or more charges on the ions are involved. The crisscross rule and Roman numeral or classical method for multivalent elements. The negatively charged radical must not be changed or reduced. If there's more than 1, they need a bracket. So in this case here, if I have iron 3 nitrate, that means that NO3 does not get changed. We cannot reduce these numbers, right? So this is just telling us that we have 3 nitrates. So that's why we need a bracket. Okay? Here's another example. Magnesium phosphate. Back that up a bit. So magnesium has a charge of +2. Phosphate is PO4 with a charge of -3. So we cross those numbers. And we end up with Mg3 bracket PO4 bracket 2. Okay? Another example. We'll give you two more. Calcium carbonate. Calcium is Ca with a charge of +2. Carbonate is CO3 with a charge of -2. Again, you've got to refer to your chart until you have it fully memorized. So that's CaCO3, because of course these twos would reduce. And how would we come up with the name? So name CuClO3. Well, there's no brackets, so we have to assume they both have a charge of, this has a charge of +1, this has a charge of -1. So we would call this copper 1 chlorate, sorry. Okay, and we'll just try one more of this. So if I gave you aluminum sulfate. So the charge on aluminum would be 3 and the charge on sulfate would be 2. So this is not a multivalent one. So oops, it would just be aluminum sulfate. You have to refer to your charts until you know them by heart. You'll get there. Okay? All right, so you can work on your worksheets for those. Now you can handle all the polyatomics, the binary ionics. The last thing we're going to look at, just going back to your chart, is, so we have now talked about binary compounds, ionic, monovalent, multivalent, and we've also looked at polyatomic compounds, the ones that are created with multivalent cations and polyatomic ions. The last type we're going to look at are molecular. So molecular compounds are ones that are covalently bonded nonmetals. Okay, so I'm going to have you flip to, and so there's some examples here. We're going to use the prefix method. Prefix meaning in front of, so this tells us how many of each element there is in the compound. So we're going to see that on our next page, which is this one. Okay, so we know that ionic compounds are formed when metal atoms bond with nonmetals. Non-metal atoms, sorry, there's no S there. And we name them using the rules for naming ionic compounds that we have learned up till now. Covalent or molecular compounds are formed when two or more non-metal atoms are bonded. So there's a separate IUPAC system for naming that is used for binary covalent compounds called the prefix system. Okay? In this prefix system, the number of atoms of each element in the compound is indicated using a prefix. Because these rules are for binary compounds, the ending of the second element is also changed to "-ide". And there are two additional rules. So here's our prefixes. Then I'll get to those rules in a second. So mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, deca means 10. So the two additional rules are that if there is only one atom of the first element, then a prefix is not used for that element. So we all know this one, right? CO2, we never call it monocarbon dioxide, just carbon dioxide. And Ni3 would be nitrogen triiodide. triiodide. So you keep both I's. I know it seems kind of strange because we don't really see that in any other English words, mostly anyway, but we do. Second little picky rule is that when the second element is oxygen and the prefix ends in O or A, then we omit that O or A. And here's another one that's very familiar too, CO, carbon monoxide. We don't call it carbon monoxide. So it's carbon monoxide. Just a little picky rule. Couple more examples. Diphosphorus pentoxide. Diphosphorus and N2O, dinitrogen monoxide. And also dinitrogen tetroxide. Sounds like I'm saying tetraoxide, but I'm saying tetroxide. I've dropped that A. So note when you're doing chemical formulas, no crisscross, not for these guys. Okay, so everything's right in front of you. You just have to literally name it using the prefix system. So here's some more for you to practice. I'll just do a couple of these at the bottom to show you how to write the chemical formulas. So dihydrogen monoxide, H2O. Silicon dioxide, SiO2. Okay, so it's as simple as that. So now you can work on all the questions in your package to deal with this type of nomenclature.